Okay, so for the last one, let's talk about power or work over time. Let's start with the scenario. So, merong dalawang tao daw. They want to climb the same summit, the same mountain. Pero yung isa, rock climber siya. So, he will scale the side of the mountain para marating yung top. The other one choose a easier path or easier way to climb. Trail hiker. So, lakad-lakad siya doon sa trail. Hiker siya. Who do you think is more powerful? The rock climber or the trail hiker? Let's find out. So, first, let's define power. Na-define na pala natin. Rate at which work is done. So, this is work over time ratio. So, that's your formula. That's your power equation. Work over time. P equals W over T. Standard metric unit is watt. Ano yung breakdown ng watt? Joules over seconds. Tandaan mo din tong conversion na to. Kasi some machine, it's not rated in terms of watts, but actually in terms of horsepower. For example, engines are rated in horsepower. So remember the conversion, you will use that later on. So power rating, meron power rating yung mga machines, di ba? So most machines are designed and built to do work on object, right? For example, the engine of the car is built to displace the car, accelerate the car, to be used for traveling, di ba? So all machines that are designed to do work, they have power rating. Okay? So pag may malaking power rating yung isang machine, that means that that machine is capable of doing very good amount of work in a period of time. Okay? So there's a relation here, power, time, and work. So the power equation suggests that a more powerful engine can do the same amount of work in less time. Pag mas mataas daw yung power rating ng isang car, mas madaming work yung nagagawa niya over the same period of time or in lesser time, nagagawa niya yung work. For example, if you have a 40 horsepower engine, kaya niya mag-accelerate ng car from 0 up to this speed or velocity sa loob ng 16 seconds. But kung papalitan mo ng 4 times how do I say this? Larger power rating yung engine, like for example 40 horsepower naging 160 horsepower na, it can do the same amount of work, diba? Kasi the same from 0 to 60 siya din, ganun din ang gagawin niya, but in lesser time, only in 4 seconds, diba? So 4 times faster niya ma-accelerate from 0 to 60 yung car because the engine has a larger power rating. That means ano yung relationship between power and time? Inverse relationship, diba? With the same amount of work, pag mas lesser time ang nakonsume mo, pag magawa mo yon, ibig sabihin mas powerful or mas malaki yung power na generate ng machine na yon or ng engine na yon. O syempre yung mga tao may power rating din, di ba? Iba-iba tayo ng power rating natin. Some people are capable of doing the same amount of work in less time or mas madami siyang nagagawa in the same amount of time. Again, when I say work, I'm not talking about paperwork, schoolwork. No, di ba? When I say work, your body is capable of applying force on an object and causing it to be displaced, diba? I'll give you an example. This is a good estimate of your power rating. You may do this if you have stairs sa inyong bahay. So si Ben daw, timbang niya ay 80 kg. Gusto niya akitin yung stairwell, yung stairs, 20 meters yung taas from the ground. So that means the height of the stairs is not 20, 2 meters. Nagawa niya lang yon sa loob ng 1.8 seconds. Narating niya yung top. The time is 1.8 seconds. The question is, what is his power rating? Okay. Power rating. PW over T. So, work is force times distance cosine theta over t. Force. What force do I need? Do Ben need rather para ma-elevate yung body niya sa stairs? Ang taas ay 2 meters. So, meron siyang timbang, di ba? Let's compute for the weight. 80 kilogram times 9.8 meter per second squared. So, calculator, 80 times 9.8, 784. 784 newtons. So, this is the timbang or the weight of Ben. So, kung gusto niya ma-elevate yung katawan niya na may ganyang timbang, he has to push his body or his whole body dun sa stairs. And by virtue of the third law of motion, if he push down on the stairs will also push him upwards. So in that way, he will be able to elevate himself dun sa stairs, to the top of the stairs. So, the force needed here is actually equivalent to the weight of Ben. So, 784 newtons. Now, what's the distance? So, from 0, diba? From the bottom of the stair, 0, until the taas is 2 meters. Cosine is 0 because your force from the stairs, reaction force is upwards. Displacement is also upwards, diba? Oh, gano'n yung kabilis? 1.8 seconds. Calculator, 784 times 2 divided by 1.8. 871 watts. Wow, that's the power rating of pen. Okay. This is another formula. Diba yung work? That's force times displacement, right? Pero yung displacement divided by time, delta x, diba? Over delta t or t. Diba? That's actually velocity. So power can actually be computed this way. Force times velocity. What does it mean? A powerful machine ay capable of na magbigay ng malaking force and na magresulta sa strong enough to apply a big force to cause a displacement in a small amount of time. It's a powerful machine. Okay, so dapat yung machine both powerful and fast. Let's solve some problems. Two physics students, Will and Ben, are in the weightlifting room. Si Will daw lifts the 100-pound barbell over his head 10 times in 1 minute. 1 minute. Pero si Ben, ginawa niya lang yon 10 times in 10 seconds. Grabe. Mabilis siya. Which student does the most work? Which student delivers the most power? First question. Which student does the most work? Sino mas gumawa ng mas maraming work? May pinakaiba ba yung ginawa nila? So, of course, none. Kasi, pares lang naman ng beses tinaas yung same barbell, di ba? So, they did the same amount of work. But, who delivers? Or who was able to generate more power? Kung sino yung gumawa ng work ng mas mabilis, di ba? Who is Ben. Ben did it. So, both of them did the same amount of work, but Ben delivers the most power. When doing a chin-up, a physics student lifts her 42-kilogram body at a distance of 0.25 meters in 2 seconds. What is the power delivered by student's bicep? Chin-up. Yung parang may bar and then, oh God, kailangan mong iangat your body, elevate your body. So, kailangan mong gamitin yung biceps mo to elevate your head up to your shoulder. 42 kilogram daw yung timbang niya. Distance of 0.25 in 2 seconds. Okay. So, definitely, the force na kailangan ng biceps ay kailangan niyang mabuhat yung ano niya, di ba? Yung timbang. FD cosine theta divided by time power. So in order to lift his body, yung biceps ng physics student, kailangan mag-apply doon sa handle ng same amount of force equal to the weight of his body. So we will compute for the weight. This F, we will compute for FG, or the weight. 42 kilogram times 9.8 meter per second squared. Gano'ng kataas niya nataas? 0.25 meters. Cosine 0. Diba? The force to lift the body is upwards. The displacement of the body is also upwards. Time, 2 seconds. So, calculator. 42 times 1.8 times 0.25 divided by 2, 51.45. Okay, 51.45 watts. An escalator is used to move 20 passengers every minute from the first floor of a department store to the second floor. Second floor is located 5.2 meters above the first floor. The average passenger mass is 54.9 kilogram. Okay. Power requirement of the escalator in order to move this number of passengers in this amount of time. Okay. So, ang kailangan buhatin ng escalator ay yung weight ng passenger, di ba? So, dapat magbigay siya ng force, upward force na equivalent doon sa weight noong passengers. So, anong work ang kailangan niyang gawin? FD cosine theta time para makapit natin yung kanyang power requirement ng escalator. Assume muna natin na iisang tao lang yung let's assume that we will only be moving one person upwards. Okay? So, and then multiply na natin sa 20 later on. 54.9. That's the kg. Remember, we're computing for the gravitational force. Times 9.8 meter per second squared. How high? Actually, multiply natin sa 20. 20 people, 5.2 meters. Cosine 0. The force is upwards, diba? Displacement is upwards. So, 0. Every minute, 60 seconds. Okay, calculator please. 54.9 times 9.8. Siya. Divided by 60 seconds. 932.57 watts. Yun ang kailangan ng escalator. Okay, I believe that's the last one. I hope you learned a lot. I'll see you next time. Bye-bye.